This is Chapter 13, the C preprocessor. Use the # include to develop large programs. Use the # define to create macros and macros with arguments. Use conditional compilation to specify portions of a program that should not always be compiled, such as code to assist you in debugging. Display error messages during conditional compilation. Use assertions to test whether the values of expressions are correct. Okay, C preprocessor executes before a program is compiled. Some actions it performs the inclusion of other files in the file being compiled, definition of symbolic constants and macros, conditional compilation, program code, and conditional execution of preprocessor directives. Preprocessor directives begin with the #. Only white space characters and comments may appear before a preprocessor directive out of line. And we've been using the # include in multiple places in this course. And this causes a copy of a specified file to be included in the place of the directive. So instead of having to code in every program, we can have it in a separate file, and we do the include and it brings it in. Even more than that, if we have it in a separate file, if we need to make a change to that file, then it's propagated through all of the programs once we recompile them. And now here, these are the two forms. You have the less than, greater than after, or the quotes around it. Difference between these is the location of preprocessor begins searching for a file to be included. If file names includes in quotes, the preprocessor starts searching in the same directory as the file being compiled. And may search other locations too. This is if you define your own header file. Now, if you got the less than and greater than, those are your standard library headers. We're seeing now here's the I/O that we've been using, standard I/O. That's what it's talking about there, standard I/O. Header containing declarations common in the separate program files often created, included in the file. Now you have a define directive, creates symbolic constants. Constants represented as symbols and macros, operations defined as symbols. The define directive format is # define, identifier, replacement text. Now, what this does is it goes through your program, and wherever it finds the identifier, it replaces it with whatever the replacement text is. Like this right here. Equals %f/n and prints out. Again, it goes through and just does a replacement. So it goes through and replaces this with 3.14159. So that's what the preprocessor does. Goes through and does all those replacements. You might say, well, why don't I just put 3.14159 down here? Well, the idea would be that if you use it in multiple places, if you need to change it, obviously pi you wouldn't, but if you had something else you need to change it, you change it in one place and it's propagated throughout your entire program. Even more than that, it makes it, when you're reading this, you know exactly what we'll deal with pi. So self-document. Everything right of the symbolic constant name replaces the symbolic constant. For example, define pi equals 3.1414159 causes a preprocessor to replace every occurrence to the identifier pi with 3.14159. Everything to the right of the symbolic constant name replaces the symbolic constant. So I wonder what you're talking about there. They don't really indicate. I was thinking it would, everywhere there's a pi, it would put that 3.1414159 at, but obviously not. Everything to the right of the symbolic constant name places a symbolic constant. I don't see anything wrong with that. But I'm probably just missing it. Okay, macro is an identifier defined in # define preprocessor directive. This is an example of it. And so you define a circle area and then pass in an x, and then it calculates pi times x, like pi r squared. And so whenever you use circle area and then whatever you pass in appears in the file, the value of y is substituted for x in replacement text. Excuse me. Symbolic constant pi is replaced by its value defined previously, and macro is expanded in the program. Excuse me. So here, after the preprocessor gets done running, this circle area you see right here gets replaced by this right here. One of the benefits of that, it says then at compile time the value of the expression is evaluated and assigned to the variable area. Parentheses around each x in replacement text forces the proper order evaluation when the macro argument is an expression. The other way would have some overhead associated with stacks. And so this would get rid of that issue, but still perform as a function. Says macro circle area could be defined more safely as a function. Performs the same calculations macro circle area, but the function's argument is evaluated only once when the function is called. In the past, macros were often used to replace function calls with inline code to eliminate the function call overhead. Today's optimizing compilers often inline function calls for you, so many programs don't no longer use macros for this purpose. Remember I was talking about the stack, the function call overhead. Whenever you call a function, it places information on the stack. And then when the function's done running, it retrieves that information off the stack. So again, has overhead, but it sounds like the compilers nowadays handle that issue for you. Define a rectangle, passing in two parameters, and the area of rectangle is length times width. So again, when that gets expanded, it comes down here, and you're passing in parameters a plus 4 and b plus 7, and it's going to actually expand it this way, a plus 4 and b plus 7. So it's not going to take the value of a and b and plug those in directly. Those still are defined by what's above it. Again, very important, evaluate expressions, evaluate at runtime, and assign to the variable rectangular area. You can symbolic constants and macros can be discarded by using the # undefined preprocessor directive. I think you see those very much. Macro commonly defined standard IO.h header is # define get char, and then get c, and then standard in. The get char is a little bit easier for us to perhaps work with. So macro definition of the get char uses function get c to get one character from the standard input stream. Put char, again, I really don't know why they don't put those in the base language instead of putting them into standard IO.h. Maybe because you don't want to put it in something in the base language. If you can put it into a separate file that only is brought in when you need it, keeps your program smaller. That's probably the main reason. Conditional compilation. It enables you to control the execution of preprocessor directives and compilation of program code. Here's an example. If, and that says defined, so if not defined, my constant, then you define my constant as 0 and if. Every # if ends with a # end if. And if def and if in def are shorthand for if defined and if not defined. These directives are frequently used to prevent header files from being included multiple times in the same source file. During program development, it's often helpful to comment out portions of code to prevent them from being compiled. If the code contains multi-line comments, / asterisk and *, these cannot be used to accomplish this task, but such comments cannot be nested. Instead, use the following preprocessor construct: if 0, # if 0, and end if, and then code prevented from compiling. Now, if you wanted to compile, you put a 1 there. Conditional compilation is commonly referred to as debugging aids. You know, and I don't think I've ever used the debugging of code blocks. I don't know how it works, to be honest. Okay, click here for the breakpoint. Debug, active, debug. So this one says, zone says something. What's this one? I swear those popped up with what they are. Cut, okay, it does there. Run, build build and run, rebuild, abort, debug. Previous default GDB, let's choose that. I don't know, never have used it. Attach to process. Okay, let's do attach. No. Well, that's a puzzler on that. Let me just because I'm curious. Code blocks. Breakpoint debugging. Nothing about C++. Okay. Project, choose constant. Okay, choose C. The project. Place a check mark by the create debug. Choose a build target. I don't know. I won't waste time on that. Okay. This is what I like to do. Certain conditionally compiled, or not conditionally compiled, but in certain printf statements to just print what's going on. I don't focus a lot on the debugger because depending upon where you're going, some of you are going where you use GCC on Linux, and it does not have one of those breakpoints and debugging features. Okay, the error directive prints an implementation dependent message including the token specified in the directive. Pragma directive causes implementation defined action. Pragma not recognizable implementations ignored. Pound and double pound are available in standard C. Pound operator causes a replacement text token to be converted to a string followed by quotes. And the pound operator concatenates two tokens. Okay, spend much time on that. Line numbers. The #line preprocessor directive causes subsequent source codes to be renumbered starting with the specified constant integer value. #line 100 causes starts line numbers from 100 beginning with the next source code line. Predefined symbolic. So here's I think those are 2 underscores or 3 line, file, source file, date, time, so forth. Assertions. The assert macro, defined in the assert.h header, tests the value of an expression at execution time. Value expression is false, 0 is assert prints an error message and calls function abort. Terminate program execution. This useful debugging tool for testing whether a variable has a correct value. There's your assert right there. Assert x is less than or equal to 10. So if x is greater than 10, then when a preceding statement is encountered in program, error message containing line number and file name is printed and program terminates. And secure C programming. So that pretty well covers that chapter. Chapter 14, other C topics. And again, we're not going to spend a huge amount of time on some of these. Maybe because, well, we're not running Linux, but some of this is very specifically Linux, Unix, and some Windows too. Redirecting I/O. Command line applications, normally input is received from the keyboard and the output is displayed on the screen, standard output. In most computer systems, it's possible to redirect inputs to come from a file rather than a keyboard. The idea would be all the prompts that you'd have a user input in, you could bring in from file. Benefit of that is if you're testing your program, you're trying to debug it and you run it 200 times. And 200 times you have to enter in 5 numbers. Well, that's a lot of work. And I don't even know how you do this on Windows, to be honest. Linux I've done it with, but Windows not so much. Several ways to redirect input and output from the command line. That is a command prompt window in Windows. Okay. So, let's see. int num scanf %d and num and d. So 3. And that's where I'm at. Programming projects test.exe. What did I say I was? Documents, programming projects. Okay, so those are test.exe. Test, and need to create a file. Add 5. Save. input.txt. So test.exe, and I'm bringing the input.txt. I can't bring it in that way, but test.exe. The input.txt. You notice that it's bringing in my input from the file into the executable. Now that's common over in Linux. Probably not as common in Windows because we got a nice GUI we're running it from Windows. Why would you go to the command prompt to do it? Well, again, if you're bringing in 100 numbers, then you probably do want to do it that way. You don't want to run it from the nice GUI. Okay, so that's what I was talking about, bringing that in. It's been a while since I used Linux. It kind of looks like a pipe symbol. I thought it was the less than in Linux, but maybe not. The greater than is how you redirect output. I don't know how you do that in Windows both at the same time. I wonder if you can just put out.txt. And notepad out.txt. Yeah, sure enough. So in the same line, you can have your input coming in, and then you do your greater than for your output. Realize when you create a C program like that, that's one that you can run from the prompt right there. You don't have to run it from code blocks. You can create an icon that runs that exe. Now, since it's console, it'll run it and then exit off real quick. But you can run it. Okay. The append is a greater than, and that'll append on to the existing file. This is helpful if you're trying to do like log for some reason, like you want a daily log that the program ran. Then you can do that. Variable length argument list. I'm not sure if they give a code example on that. There we go. So we've got our include standard argument.h, and then down here our prototype. Notice the 3 dots. Then down here for the average, when we call it, see how there's 3 items we pass in. Here there's 4 items we pass in. There's 5 items we pass in. And the actual definition over here is you got ... And so stores information needed by VA start and VA end, initializes a VA list object, and then is looping through each one of your arguments with this. Where would this be beneficial? Well, if you're figuring like the average, and you don't know how many numbers you're going to pass in. Well, you might say, well, that doesn't make any sense because we're going to ask the user for the numbers. Shouldn't we know how many we're going to have? Not if you're putting this in its own separate code file. And you're going to provide it as a capability for somebody to bring it into their program. So they never have to program average again. Then you don't know how many numbers they're going to put in. That talks a little bit about that code. Command line arguments. Let's see if there's a code example here. Here's how you have your command line arguments passed in here. This checks the number of arguments. If it's not equal to 3, then you print usage so they know what they're going to be passing in. Not equal to 3. Why is it checking not equal to 3? Because that usage implies that you're going to have 2 arguments. Unless the program is one of them. Because argument 1 is our in file, argument 2 is our out file. Now that only works if you're running it from command prompt. But some development environments allow you to set your parameters. And I don't know if this one does or not. There it is. Program set programs arguments. Maybe. Did I click it? That's strange. Unless I need to actually have something like this. Maybe it sees a void and says, okay, there isn't any arguments. argc, comma, character, outside arg, v, bracket, an array. Okay, now let's try set. Still not. Unless I'm just missing it, I don't see it on the screen. Okay, project, set programs argument, didn't appear there. I don't know if it appeared here. I don't see it popping up anywhere. May not be working. Okay. The idea is when you run it, I'll show an example. But the idea is when you run it, then you can pass in the parameters there. So like down here, test.exe, test.exe 134. Okay, so these are parameters I can pass in. So you could write a program to calculate the average, where you type in average and you put in your numbers like that, and that would return the average of 3, 5, and 6. We don't really work with multiple source file programs in here, but if you wanted to read that, you could. This is something that's kind of handy. On Linux Unix systems, the utility is called make. Utility make reads a file called makefile that contains instructions for compiling and linking the program. Products such as Eclipse and Microsoft Visual C++ provide similar utilities as well. The idea is if you are working with a complex program and it has 200 C programs that correspond to it, and you need to compile them for your specific machine. They don't necessarily come down in a binary format, and some people don't even like binary because they want to see the source code they're working with. And so instead of you trying to figure out how in the world I load these 200 programs, 200 C programs, and compile them, then you got a make utility that, based upon the make file, goes through and generates all that. Function exit causes the program to terminate. Function add exit registers a function that should be called upon successful termination of the program. So there's the add exit print, and then you see down there it says exit success. And here's our print, the program that'll run. So executing function, print a program, termination, program terminated. Suffixes for integer and floating point values. By putting 174, that's an integer. When you put a U on the end, that tells it, okay, it's an unsigned integer. By putting a capital L, by putting a UL, by putting a U on the end. No, that one, last one's LLU. All of these are ways to tell it what's that data type going to be. So saves, some cases saves memory, because some of the integers with an unsigned integer, you don't have to worry about the negatives. So it takes up less space. F for float, capital L for long double. You see this a lot more. I never really see this a whole lot in the basic C programming class, but you get more advanced C programming, or you go into other languages like C+, or not C+, C sharp. C sharp, you have to put that F on there to tell it's a floating point. Otherwise, it assumes 1.28 is a double. I don't know if how this would actually handle it. And not my code blocks. Must have closed it. But we'll see. It was one of those mornings I woke up not feeling too good. I could have slept till noon, I think. Okay. Now that worked just fine. I declared a float f and I said f equals 1.23. Some programming languages will assume this is a double, and you cannot assign a double to a floating point value. But if you put an f on there like that, then they do let you do it. So anyway, signal handling, you got interrupts like Control C, so forth. Signal handling library signal.h provides the capability to trap these unexpected events. That's interesting. You see this a lot. I see it over and over in Xcode, Sigabert, abnormal termination of programs, such as a call to a function abort. I don't know how many times I've seen Sigabert pop up, but these are standard signals. Makes me wonder if Xcode is written in C. At least it shares that signal anyway. I wouldn't think it'd be at the operating system level, because we're on Windows 10 now, and that's a Mac. And this is an example of how to raise a signal. Okay, dynamic memory allocation, calloc, alloc, and realloc. Allocate. There you go. I get the word out. Induces chapter 12 introduced the notion of dynamically allocate memory using malloc, and so we got general utilities library, standard library.h provides two other functions for dynamic memory allocation. So those two. calloc dynamically allocates memory for an array. Difference between malloc and calloc is calloc clears memory, it allocates, and malloc does not. Function reallocate changes the size of an object allocated by previous call. Unconditional branching with the goto. I'm not even going to cover that. You shouldn't be using gotos. Goto statement can be used to exit deeply nested control structures efficiently. Yeah, but it's bad programming. And here's what I was talking about. The goto statement is unstructured and could lead to programs that are more difficult to debug, maintain, and modify. Some programming languages do not even provide a goto feature. I mean, you should be desperate before you use a goto in your code. And that's it for that chapter. Okay. So I'm going to go ahead and save out the recording. I should mention next week the final project's due. Let's see. Some of you have been emailing me your source code from past projects, and that's fantastic. I'll get those updated. I'm working on this week on getting all those recorded and everything. But final project under course content, and it's under Unit 13. I guess I could rename that. so you know where it's at. And if I go there, this will talk about the final project. There's two parts there. It's due a week from today. So next week I won't be covering any material. I'll just be getting on to see if you're having any trouble submitting it through Blackboard. If you are, then I'll probably just tell you to email it to me. But after that, then we're all done for the course. Anyway, this will be my last recorded message in this class. So if I don't talk to some of you again this semester, I want to wish you a good break over the summer. Hopefully you're staying healthy, not getting any kind of virus or anything. And have a good day.